In this lesson, I'll show you how to solve second-order differential equations with the right side equaling to 0. This is part 1. The first question reads, solve the equation y double prime minus 3y prime plus 2y is equal to 0. The first thing that you'll notice is that each term on the left contains y, or its first or second derivative. Therefore, a possible solution is a function such that it and its derivatives are alike. With that being said, if you visually inspect this, you'll notice that it looks like the auxiliary equation of a second-order differential equation, am squared plus bm plus c, and this happens to be a quadratic. Therefore, what I'll do is replace this y double prime with 1m squared, replace minus 3y prime with minus 3m, and replace 2y with simply 2. And this is equal to 0. What we have here is a quadratic that is factorable. Take a look. What two numbers multiply to 2 and add to negative 3? The answer is negative 2 and negative 1. So we have m minus 2, m minus 1 is equal to 0. If I solve for m, I end up with m is equal to positive 2 and m is equal to positive 1. Now, using the general solution of a second-order differential equation, my answer is y is equal to c1, my constant, times e to the power of m1, which we can use any of these. I'll just use 2x, plus c subscript 2 times e to the power of 1 times x, which is simply x. And that right there represents the solution for question 1. However, in question 2, you'll find out that sometimes one root of the auxiliary equation will be 0. And here's how to tackle that. The question reads, solve the equation y double prime minus 5 times y prime is equal to 0. This time, our auxiliary equation will look like this, where this right here represents m squared, and it has a coefficient of 1. And over here we have minus 5m plus 0 is equal to 0. This simplifies to m squared minus 5m is equal to 0. And this factors into, if we common factor an m, pulling out one m from each of these terms, we're left with 1 times m, or m, minus 5 is equal to 0. Therefore, m is equal to 0 and m is equal to positive 5. Our solution needs to follow this general solution. So we have y is equal to c1, e to the power of, let's call this m1. So we have e to the power of 0, which is equal to 1. So I'll change the e into a 1. So we're left with c subscript 1 instead, plus c subscript 2 times e to the power of our second m, which is 5x. And there you have it. That is how to solve second-order differential equations with the right side equaling to 0.